In this section, we're going to be solving application problems involving proportions. And these are actually a really nice kind of problem to solve because once you get the hang of them, they usually go pretty smoothly for people. So let's kind of talk about what we're doing. There's some steps involved, and what we'll do is we'll just go ahead and start with the problem and then kind of see how it works with the steps. So the first problem asks us to set up and solve a proportion. So even though this application problem could be figured out without setting up a proportion, in this section, we're going to ask you to go ahead and set up the proportion and solve it that way. And I know this might be a little hard to read on the screen, but you should have this handout, and then you can read it there. So the first one says, Sean decides to mow lawns to earn some extra money. If it takes him 25 minutes to mow 3,000 square feet, how long will it take him to mow 4,200 square feet? So I am trying to find how long it will take him to mow 4,200 square feet. So I'm going to have a variable. I can let x be the time to mow 4,200 square feet because that's what the question is asking me. When it says set up a proportion, I know proportion is two equal fractions, so I'm going to make two fraction bars with an equal sign between them. And then what they're going to do in each of these problems is tell you some kind of relationship or rate that you can put as one of the sides of the proportion. In this case, the known relationship is 25 minutes to mow 3,000 square feet. So I'm going to put 25 minutes to mow 3,000 square feet. So now I go to the other side of the proportion, and I know that I'm trying to find how long it will take him to mow 4,200 square feet. The key to these is if I have square feet on the bottom on this side, I'm going to put square feet on the bottom on the other side. So the units and the denominators will match, and the units and the numerators also will match, because what I'm going to put up here is that I don't know the minutes that it's going to take, but the minutes will be related to the 4,200 square feet. Once I get it set up as a proportion, I can do the cross product. And I'm not going to worry about units as I do my problem. I'm just going to go 3,000x equals 25 times 4,200. And that's 3,000x equals 105,000. And then divide by the 3,000 to solve for x. And I will get x equals 35. And then since this is a story problem, it should have units, and it was asking how long. X was the time. Time is measured in minutes, so 35 minutes would be my answer. So in order to do this problem, I need to set up a proportion, which means I'm going to show two fractions with an equal sign in between. There's going to be a known relationship. There's going to be a variable that I've defined. And there's going to be a number that I'm given. And then I will solve for that variable. I can use the cross products to solve it. When I get the answer, I want to make sure that I have the correct units and that it answers that question. So those steps that I just talked through are kind of right up here to remind you. There's 3 more problems of this type on here, and if you kind of have a feeling for it, you might pause the tape and try those problems and then come back and watch the rest to make sure you got them set up right. So I'm going to go ahead and set up the other 3 problems. So it asks how many milligrams the nurse should administer. So I'm going to x equal the number of milligrams. 2 equal fractions per proportion. I know the drug is available in a concentration with 50 milligrams per 0.9 milliliters. That's my given relationship. So I go 50 milligrams for 0.9 milliliters. I know that the nurse needs 220 milligrams. So when I go over here, milligrams is on top, so I'll have to put milligrams on top here. And I'm trying to find out how many, this was how many milliliters of solution. How many milliliters of solution? Milliliters. So I'm going to put X down here because that's the milliliters. So I do my cross multiplication. 50x equals 0.9 times 220. And when I multiply that out, I get 50x equals 198. Divide by the 50. X equals 3.96. And it was milliliters I was looking for, so it's milliliters of solution. Okay. Number 3 says they're 2.54 centimeters in an inch. That's a given relationship. That's always the same. You could kind of look that up in a table. And how many inches are there? And 635 centimeters. So this is a unit conversion going from one type of units to another as a common use of proportions. So I set my two equal fractions. The one relationship I know is there's 2.54 centimeters for every 1 inch. I want to know the number of inches, so let me say let x equal number of inches and 635 inches and 635 centimeters. Okay, so I'm going to put 635 centimeters. Centimeters were on top, so I'll put centimeters on top, and my x is inches. Do my cross multiplication. 2.54x equals 635 times 1 is just 635. And then divide by the 2.54. And I'll get x equals 250 inches. The final one on a map, 0.5 inches represents 22 miles. What will be the length on a map that corresponds to a distance of 55 miles? So I'm going to be x equal length on map. Set up my two equal fractions, since I'm supposed to set up a proportion. Oh, excuse me, I'm going to scoot that up. So I have this relationship for the map. 0.05 inches is 22 miles. I know that I want 55 miles, so miles was in the denominator, so I'll keep it in the denominator. And then my unknown, I'm trying to find the inches on the map. Do my cross products. 22x equals 0.5 times 55. 0.5 times 55 is 27.5. And when I solve that out, I get x equal 1.25, and the units on here are inches. So one other thing that will come up besides these story problems with proportions is the idea of similar figures. So similar figures are two figures that have corresponding angles that are equal and corresponding sides in proportion. The way I kind of picture similar figures is if you took a shape and you put it on a copy machine and you chose enlarge and just had that same shape but bigger, that would be two similar figures. Or if you took the bigger one and you chose reduce on the copy machine. So the corresponding sides are in proportion if figures are similar. So what I could say is if I took the smaller figure, the top compared to that little slanty side could be one side of my proportion. And the top of this larger one compared to its little slanty side would be the other side. So top compared to slanty side, top compared to slanty side. So I have the same part on the tops and the same part on the bottoms of the two fractions. Cross multiply, and 5 times 15 is 75, and then divide by the 6. X equals 12.5, and my units here were meters. So that's one example. We'll look at one more. Here they talk about triangles ABC and AB prime C prime. So a big triangle and a small one. What they've done is they've taken the smaller triangle and just put it on top of the big one. They could have written it one triangle and then the bigger one side by side, but sometimes in the books they do this too, so I thought I'd show one that way. So again, I have two triangles, and if I set up my proportion, the height of the large triangle compared to its base will equal the height of the small triangle compared to its base. So I use the numbers right off the diagram, and then I can do my cross multiplication. Get 9x equals 122.4. Divide by 9. and x equals 13.6, and the units were inches, so always remember to put the units back on your answer.